right, let's go ahead and start. I give you guys a little more time, a couple more minutes if you need it later. If I want to get going. So our quiz today is going to be doing that last problem, the shopping bag problem on Chapter 11 notes. And then we're going to finish up we're going to do Chapter 11.2, which we touched on a little bit last class. We just did the preview, I think, of it, and 11.3. You have Connect Math 10.2 and 11.1 due tonight, along with Lab 10. You need to do that in Excel, and you need to do it on the web version of Excel. You can't let someone in another class try to do it using, I guess, like a web version, right? And that didn't work. It didn't have all the stuff available. So don't use the web version. What she did was I just had her save it to the computer and then open up in Excel itself, and then it was all great from there.
Yeah.
And then you can always save that back, and you can use it to print from, but you need to get it from there. Thursday you can do Connect Math 11.2 is due. We're going to cover 11.2 tonight, so not a lot of time. You only have 2 days to do that homework from when we kind of learned it. Sorry, that's how it goes.
It's fine.
And also you can turn in Lab 10 late, but for full credit on Thursday. Sunday you have a Connect Math 11.3 due. The final's next Thursday. And again, about 35% of it's going to be on these two chapters, 10 and 11, because the exam 4 is rolled into the final. You can take this final early next Tuesday in the morning. I'm going to have it at 9:30. It's technically 9:30 to 11:30, which is ridiculously early. But I'm also going to let students take it from 11:30 to 1:30, since that's kind of more our normal class time. So you can take it to either one of those, but don't come in between. It's got to be either the 9:30 group or the 11:30 group. I can't have people starting, in between. Does that make sense?
Uh-huh.
So you can take it at 9:30 or you can take it at 11:30 on Tuesday. Our final is going to be, like I said, on Thursday in class, so 7:30. Good? Okay. I have a review session next Tuesday, 5:30 to 7 and 7 to 8:30 here, because we don't have class. Thursday is our last class. Next Tuesday, I'm going to go through chapters 1 through 6, which you have probably all long forgotten. So Tuesday we'll go over those chapters if people want to review those. And then my plan for Thursday is to go over these chapters 10 and 11 and try to figure out how to tell them apart, right? And then how to tell those apart from the ones in chapter 7 and 8 and 9. And then maybe if we get a chance to touch on like chapter 2, because it's been a long time, or maybe chapter 7 4, since it's been a long time, one of those guys. Are you guys interested? And I think you guys are interested in doing a potluck on Thursday, this coming in 2 days, right? So bring food. I'll pick up a pizza from Costco, which might be cold. Is anybody coming from that area, through there? If I gave you money, could you pick up a pizza for me? Because I have class before that, and it'll get cold between, if you guys are okay with that, I'll just get it beforehand, and it'll be sitting around cold. I'll have to stave off the other class if they get hungry.
Stave off.
All right.
Sure.
All right, so I'll give you money. Cheese, is cheese the best? Because it's the simplest, everybody likes that. All right, good deal.
What are you, preschool?
But yeah, so bring something to drink or something to eat. Snacks, chips, whatever.
Okay.
Burned bread, whatever.
It
was really good, and it was not burned.
Okay.
All right.
Okay.
Last time. I ate all the burnt before bringing it.
This is your study guide for the final. These problems from those different study guides. And it's on Canvas, should you need it there. On your study guides. Here are my office hours for next week. I'm also in 610 on one of the days. Tuesday, I'm in 601. From, I think it's 2:30 to, let me see. Attachments, Ashley McHale. I think I'm in there. I'll just look at it. I'm in there Tuesday from 3:30 to 5:30. well, not quite 5:30, because I'm going to take off shortly before 5:30, so I can get here by 5:30. 3:30 to 5:30. We'll say 5:25. And I'll wander over here and I'll do the review session. So if you guys have if you guys have questions, you can also talk to me there in 601. The ones in blue are the review sessions. So if you have questions about other stuff, like I want to know what to do with the rest of my life or whatever, right? Then talk to me during the other times.
Thanks.
Okay. Are there any questions on Lab 10? And the main issue people had was they're using that web version, which didn't give them all the options. But yeah, so if you actually open it in an actual copy of Excel, I think it should be all good. Okay, great. So you guys, oh, I did that already. Why am I doing that again? Do that, again, let me emphasize that here. Prep to Pass is going on right now at this moment. December 10th, and it's also going on tomorrow from 6:30 to 9. They have pizza in there, and they have snacks and stuff like that. The pizza is almost all gone. So I'll take snacks instead. I didn't want to deprive students of pizza. That would be bad. But they're studying all sorts of stuff. So you can go in there and study with groups. They have tutors there. There's, not just statistics, but like, lesser subjects also are in there.
Lesser subjects?
Oh my god.
Ouch.
Whoa. Personal.
All right. Let's get a reader. Jimmy, you want to go and read?
11.1 Test for Goodness of Fit. The chi-square statistics can be used to see whether frequency distribution fits a specific pattern. This is referred to as chi-square goodness of fit tests, which test the claim that an observed frequency distribution fits some expected frequency distribution. H naught is O sum I equals E sum I. H1 is O sum I is not equal to E sum I. What actually occurs equals what's expected. What actually occurs is not what's expected.
Right, so what occurs, O, and then it's a subscript, O subscript I, so we call it O sub I. It's the same as E sub I, so what actually occurs is what we expect, what occurs is not what we expect. Please note that the observeds obtained from a sample are the observed frequencies, and the ones observed by calculation, obtained by calculation, are the expected frequencies. So the ones you actually see from a sample, those are your observeds. The ones you have to calculate, take your n and multiply it by some decimal, or divide it by some number, that's going to be your expected number. So in other words, you can, if I flip a coin 3 times, how many heads do I expect to get? Flip a coin 3 times. How many heads? 1.5.
Yeah.
How many tails? 1.5. So you can expect 1.5 heads. You're never going to observe that. Right? Okay. So your expecteds can be decimals. The formula for goodness of fit, we talked about this before. It's your O sub I minus E sub I. Every observed value minus the expected value squared divided by the expected. We do that for every category, and then we sum them. We add those up. That's your chi-squared. Degrees of freedom is the number of categories minus 1. You can also calculate it using a calculator. However, I still want you to handwrite out the formulas with the numbers in them. 20 minus 33 squared divided by 33. Plus 19 minus 42 squared divided by 42, plus so forth. There's only going to be like 3 of them, so it's not that hard. But to calculate it, the actual amount, you can put the observed values into list 1. You can put the expected values into list 2. And then this part right here, you'll calculate that with this. In list 3, you're going to put in L1 minus L2 squared divided by L2. That's that part there. And then the last thing you need to do is sum it, right? So the summation, that's going to be the sum of x when for stat calc. Oh, sorry, stat calc.
1 bar.
1 bar stats. 1 bar stats of L3. And then just find the sum of x's, and that will be your chi-squared. Because that's that last step, summing, adding them up. Or you can just add them up if you wanted to. You're right, also. Okay. Here's the summary. Do you guys need just another minute? Step 1, obviously, we talked about that already. Step 2, find the critical value using alpha and your degrees of freedom k minus 1, number of categories minus 1. Complete your test stat. And the rest of it's the same. Steps 4 and 5 are the same as everything else. So, 1 more minute, or are you guys ready to go?
Ready.
Ready to go.
Ready to go? Okay. We'll go ahead and start in on that then. Please note, okay, so let's take a look. So here we have shopping bags. What kind of shopping bags people could use? Reusable, right?
Plastic paper.
Plastic and paper. Good. Please note that these categories are in this order on the top when you first see them. Reusable, plastic, and paper, right?
Uh-huh.
But then later on when they give them to you, they give them to you in a different order. Paper, plastic, and then reusable.
Yes.
You're going to find that on one of your homework questions due tonight as well. Due tonight, yeah. So they're going to mix up those orders. They're going to give it to you in one order, and then they're going to give you the other information, the other one, in a different order. Right? So don't get, tricked by that. Okay? Because otherwise, my student spent like 2 hours, and she solved 10 different similar problems. And thinking that, well, this one will work. No. So it just was, I'm sure she got very good at computing these, but it was a nightmare, right? So,
It was a nightmare.
yeah, I mean, totally, right? So just pay attention to that, to where they'll rearrange that. They'll be tricky and rearrange those words on you. So sort that out. So here we have our observed and our expected. What were my observeds? Let's see, I observed 28 paper, 120 plastic, and the rest, 152, were reusable. So then I went to compute my expected. So my expected, let's see, we have 60% of 300. Remember, you've got to do six. You can't just put 0.60 in here because you can't compare that number to 0.60. And you can't change that to a fraction, or else otherwise you're talking about parts of a person. Parts of a person, you're never going to get a high chi-square, because it's like, well, 2/3 of the person said this, 1/4 of the person said that, and 1/12 of the person said this, and that's not very different from another. You know what I mean? It's like you can't differ by more than one person, so you're never going to get anything very real. So you have to use the actual numbers of people. That's where your n comes into play, is by finding these ones. Otherwise, it's like you've chosen an n of 1, and how different can it be? Right? Yeah.
On the final, do you want us to show that stuff, or can we, if we just have the right answer, is that fine?
I would prefer you to show it, but if you have the right answer, that's okay. All right, and then this next one is 32% plastic. So 30.32 times 300, this last one is 8%. 8% is 8 cents, not 0.8, 0.08, 8 cents. So this is 180, 96, and 24. And then you're going to move down to your step 1, H naught. O sub I equals E sub I. And H1. O sub I is not equal to E sub I. And then you're going to move on to step 2, which is your critical value. So here we have alpha is 0.01, is that right?
Yes. Yes.
And my degrees of freedom is going to be 3 minus 1. My number of categories minus 1. So my critical value is, what's my critical value, guys?
9.210.
210?
Yes.
Great. And that big straight up and then slowly tapers off. 9.210. Sounds like a zip code almost for. All right, and then we have our test stat. So my chi-squared is going to equal, and yes, you have to write these out.
Yes.
152
Right there.
minus 180 squared divided by 180 plus 120 minus 96 squared over 96 plus 28 minus 24 squared over 24. That was not painful. I did not die. All good, right? So what do you guys get for that?
11.02.
02. Put that in there, 11.02. 2, I think there's another 2.
Yes.
So here, am I going to reject or not reject H naught?
Reject.
Yeah, totally in that rejection area, right? So, step 4, reject H naught. You have the picture, so you have to say why. You're all good there. Step 5, we have enough evidence to... Okay, so this one says, does it differ? So I guess, technically, I guess you could say the claim is that it differs. Do people go with that?
Yes.
Okay, so then you'd say to support claim.
That it differs.
That differs from expected. That bag types differ from expected. Okay. Okay with that? On the exam, I'm going to give you stuff that I'm pretty much going to give you where H naught is your claim, that they're the same. So then you'd say reject the claim. Enough evidence to reject the claim that they're the same
Yes.
as expected. Whether they are as expected. Same as expected. Everybody understand what I'm saying?
Yes.
Okay. All right, so H naught's going to be my claim next time. I'm on the exams. Be aware of that. You're going to want to reject, looking to reject or not reject the claim. Okay, so let's hop into 11.2, which we touched on a little bit last class. I'm just going to kind of run through it super quickly. So let's get a reader. How about Abdullah? Do you have a read?
11.2 test using.
Oh wait, I'm sorry. Alyssa's got wants to volunteer first. Alyssa, go ahead.
I can't read that.
Move up here then.
When we have dependency tables, we can use the test of independence of variables is used to determine whether two variables are independent of or related to each other when a single sample is selected. The test of
Homogeneity.
homogeneity of proportions is used to determine whether the proportions of a variable are equal when several samples are selected from different populations.
Good. Thanks. So that you can. So those are the kind of two tests we're having using contingency tables. So that's when we have that table, right? We have rows and columns like male, female, black lab, chocolate lab, yellow lab.
Yep.
Good. So you either say that two things are independent of each other or not, or the proportions are the same or not. So for independence, the hypotheses would be there's no relationship, right? In other words, O sub I is equal to E sub I. Because again, no relationship, independent. I'm very independent. I don't have I have no relationships. So those go together. Independent means no relationship. All right, and then H1 means there is a relationship. So that's, you generically could use O sub I is not equal to E sub I. Good deal. All right, so if you reject the null hypothesis, that means there is some relationship. And again, so no relationship. No, also would be similar to no difference. And also it's the same as independent. So this one would be is a relationship, is different, or is dependent. It's either you're independent or you're dependent. Good? All right, so here's our formula, which is exactly the same as our previous one. The only difference is that we're totally going to let the calculator calculate it for you. You don't have to write them all out. A couple other small things. You do, however, have to figure out what the expected frequencies are. Not of all of them, just of the first one of the matrix and the last one of the matrix. So you have this matrix, the first one and the last one, you compute the expected value. That is by taking the row sum, so the sum of the rows, times the column sum, the sum of the columns for that particular spot, divided by the grand total. We're going to go through another one of those. We went through one last class, we'll go through another one today. And you have to show these calculations just for the first and last expected values. And then the degrees of freedom is a little bit different. It's R minus 1 times C minus 1. What's R stand for?
Row.
Rows. Number of rows minus 1, and C stands for columns. Number of columns minus 1. So we'll see that as we go through this example, which we did already, but we'll go through it again. Just to refresh people's ideas. Finally, the test data is going to be super, super easy, right? Because you're just going to put your observed values into matrix A. We'll go through that. We went through it last class, but we'll show you guys again this class. And then once you do that, you just do stat test, chi-square test of matrix A. And then for the expected, put in matrix B. And it will take your matrix A, it will compute all the expected values and save that into matrix B for you. It's also going to give you the chi-squared value and the p-value. So here's the summary, right, of what you need to do. State the hypothesis, identify the claim, find the critical value using the chi-square table, and degrees of freedom, again, is equal to R minus 1 times C minus 1. Incidentally, this chi-square test will also give you the degrees of freedom, so you can double check your answers to make sure you didn't screw up the critical value while you're at it, just as a quick double check. And then also find the first and last expected values. Then make a decision about H naught, and then summarize your results. Steps 4 and 5 are totally the same as always. All right. Homogeneous proportions is really similar. It's just that the proportions, you just claim the proportions are the same. Will equal. So that might look like, the claim might look like this instead. P1 equals P2 equals P3, however many proportions you have. And then, or generically, you could just use O sub I equals E sub I. And then your H1B, at least one proportion differs. Or generically, you could say O sub I is not equal to E sub I. Good. And again, when you reject from the hypothesis, then you're assuming that all the proportions aren't equal. At least one is different. All right, so we did this example last class. I'm just going to go through it again really quickly. We want to see if there's a relationship between a hospital and number of patient infections. So how many rows and columns do I have, guys? How many rows?
3.
How many columns?
3.
3. Don't count the total. You only count the data. See 1, 2, 3. 1, 2, 3. Everybody on board with that? And 1, 2, 3 there. So we have 3 rows and 3 columns. Then we need to figure out what our H naught and H1 is. So again, H naught is going to be that O sub I equals E sub I. And H1 is that O sub I is not equal to E sub I. This first one also means no relationship, because we're talking about relationships here. Everybody see that? So this would be no relationship. And this would be is a relationship. is a relationship. Which one's my claim in this case? I'm claiming
H1.
there is one.
H1.
Oh, can I change it to, do you guys mind if I change it to no? Just, you guys alright? Oh, should I just leave it like it is?
Yeah.
Okay, I'll leave it like it is.
That's
So it's
fine.
like, leave it like it is. Alright, so this is my claim. Good so far?
Yep.
Okay. Step 2, critical value. So my degrees of freedom is going to be my number of rows minus 1 times my number of columns minus 1. So my number of rows is going to be 3 minus 1. Columns is 3 minus 1. So we have 2 times 2, which is 4. My alpha is, what's my alpha? Doesn't say, right?
Yep.
So if it doesn't say, what's my default alpha?
5%.
5%. So if you look that in the table, and someone look that up on the table, let's see what you get. $9.488.
488. It's not like.
No? Yes?
Yeah.
Yeah. Great. 9.488. Terrific. So then,
Where are we?
that's that part. Now I can move on to my stat test and my expected value. So my first expected value is going to be row 1, comma, column 1. So that's going to be this fella right here. I defined his expected value. So I take his row total, 119, multiply by his column total, 246, divided by the grand total, 582. So that's going to be 119 times 246 divided by 582,
50.299.
50.299, 50.3. And then I'm going to find my expected value of 3 comma 3, my third row and my third column. Again, remember, A is my row 1, B is my row 2, C is my row 3. And then I have to call columns. So I want this far one, column 1, column 2, column 3. So it's going to be 3, 3. It goes row, comma, column. Row, then column. So I always remember it when I was a kid with RC Cola. So this is a can of RC Cola. One of my students brought it in, I don't know, a couple years ago, and then I was in the car and it exploded, so, oh well. But still, RC Cola. So that's one way of remembering it. Other people remember it from remote control. I don't know, whatever you want. Whatever works for you. But RC, row then column. So my row here is going to be 384 times 200 divided by 582. Oh, what did we get for that last time?
131.959.
131.159.
959. So 132.
132.0, I think it was. Yeah. Great. And then we need to do our stat test. So why did you find the expected values? To prove to me you can. Otherwise, I'll make you do all of them. Right? So this is proof that you know how to find those. So we're going to do stat test, chi-square test of matrix A. And here's a reminder of how to figure out how to locate matrix A. There's all these guys on. So how do you get your matrix? Second, and then matrix is the fourth one down. If you have an old 83, it might just say matrix on the button right around here. It might literally say it right on there, matrix. If so, then it's easy. You hit that button, and you get to this menu. But otherwise, it's second, and then fourth one, matrix. Go over to edit. So don't mess with names. Go over to edit. Pick the first one, A, enter. And I want it 3 by 3. So 3. If I wanted 3 by 2, I could make this 2, and all of a sudden it would change to 3 by 2. but I want 3 by 3. Rows and columns, 3 by 3. So I'll send out 3 by 3, and then just type all your numbers in. So 41, 41, 27, 51, what is that, 36? And if you look at here at the bottom, see where it says 2 comma 2 down there? That means it's the second row, second column. 3, 40, 169. Are you guys doing this? 106, or did you already? 109? Okay. And then I'm going to go, then double check and make sure your numbers are correct. Like this one's wrong. See where it says 116 instead of 169? It's going to give you trouble. Make sure, double check and make sure your numbers are all right, because if they're not all correct, big problems later. And then we're going to go to stat, test, arrow up because it's towards the bottom, chi-square test. Good? 83s and 84s will all have the chi-square test. Only some 84s will have this chi-square goodness the fit test, but we want the chi-square test. Observed value, observed, matrix A, expected, matrix B, just leave those alone. Leave them like they are. Don't mess with them. And calculate. And that gives me my chi-squared, 30.7, and my p-value. Is my p-value 3.53?
No.
No. Your probability can't be more than 1 or 100%. If it is, you better look for an E negative on the end of it, right? So it's really 6 zeros, and then 353 with the decimal place after the first 0. And then it also tells me my degrees of freedom is 4, so I can double check to make sure I got that right and did my critical value correctly. So here, what's that? It's E number 6. So here it is. Oh, sorry. I don't want to do that yet. So I've got my chi-squared is equal to 30.7, and then my p-value is equal to 6 zeros, 1, 2, 3, 4, 5, 6, it says negative 6, and then 353. And then you put the decimal place after the first 0.
Isn't it?
Then you put the decimal place after the first 0. You see what I'm saying? Yeah, because it's E negative 6. So it's the easiest way to do it.
It's 5 zeros.
6 zeros.
After the decimal place.
Yeah, so 5 are after the decimal place, but the thing is that it says E negative 6. If you want to make your life, you can either move it over 6 spots, or you just make your life easier and write 6 zeros and put the decimal place after the first one. Why not just make life easier? So I'm going to put 30.7, that's way out here. Am I going to reject H naught or not reject H naught?
Reject.
Yeah, reject H naught. So there is enough evidence.
For support.
Yeah, I think H1 was my claim, so I'm going to say to support claim. What was it, relationship? Is that what they said? Relationship between hospital and type of relationship between hospital and infection type. Okay, good deal. Everybody feel all right with that one?
Yes.
So I'm going to have you guys. So before I let you loose, there's one thing I need to emphasize. One is H naught. H naught is no's, right? No relationship, independent, right? Also means no compromise.
No compromise.
No difference, no preference, right? So no relationship, no difference, no preference. Also independent. Independent and no relationship go together. The H1 then would be is a relationship, dependent, is a difference, is a preference. There is a preference. Good? Okay. The last thing before you guys get going is, not problem 2, change this change this. See where it says there is a difference, make it there is no difference. Can you guys all change that?
Okay.
Change that to no difference, and take 7 minutes and do this problem.